Hi, this is the MedTech Mavericks podcast with me, Steve Bell. And in one of my deep dives today into the different soft tissue robotic systems, I'm going to cover the company Medicaroid and their Japanese robot Hinotori. And I would like to start by thanking Medicaroid for reaching out to me and giving me some information into their system. It was some information that I didn't have before, so hopefully this will give a really good balanced view of their product. When you talk about any Japanese company and any Japanese product, one of the first things that you really have to think about is quality. They are renowned for quality generally in life, but when you get into medical devices, that becomes a phenomenal level of quality. So Medicaroid is a company that was formed between two companies, Kawasaki Heavy Industries and Sysmex Corporation, and they were founded in 2013 and started to develop the Medicaroid's robot, which is called the Hinotori. Now, for those that don't know, or some people will know Kawasaki because they'll know about their incredibly great motocycles if you're in the US. But they have a heavy industry side, which also makes plant machinery and all kinds of things. But one of the divisions they have is robotics. And that means that they absolutely know how to make robots. And I'll come back to that later. And they know how to make robots that are reliable. They know how to make robots that are superbly high quality. And they are clearly a very great company at making high quality engineering. Then you have the Sysmex Corporation, which is into healthcare. But interestingly, they're not into surgery. So they're not a surgical company like a Medtronic or a Johnson & Johnson. So this is quite an interesting. So they've got a healthcare side that they understand, but they've got a really deep depth of knowledge into robotics. And I think that's why the two came together. And the company is based out of Japan, and that's where they started commercializing the product first. Now, I can say, again, when you're dealing with Japanese products, the quality is really high, and I have sat on and felt the Medicaroid system, and it is insanely high quality, which is what you'd expect from any Japanese company. And maybe that's a little bit why they are slightly later to the game than others, even though they started in 2013, because no Japanese company is going to release anything unless it's exactly how they want it to be. That's just been my experience of Japanese medical device companies. So the product is really, really great quality. The company has two products for those that are interested. They have the Hinotori, which is the soft tissue robot, which we'll talk a lot about today. But they also have a second product, which is called the Versia, and I hope I'm saying that right, and someone from the company can put some comments if not. But they have Versia, which is a robotic-powered table for the operating room, which was really aimed at helping to work between hybrid labs, for those that know hybrid labs, and that's coming in the future. So I have a slight suspicion that they're going to be able to get a robotic table to talk to a robotic arm. So the whole thing of table motion that Intuitive has, I think they'll be able to mimic that with the products that they have. So let me talk in a little bit about Hinotori itself and the structure of it. And you can go and see some pictures on the web. And if I put this up onto YouTube, I will try and put some images of the product up there as well. So it's what many people will call a mainframe or a large format robot. And you have three components to it. You have the bedside unit, which is a boom where four arms hang off the boom. And then you have a tower with all the smarts on it and the vision system, and a screen that helps the operating room staff to see what's happening inside in 2D. And then you have the console or the cockpit, which is where the surgeon sits and controls the system. So it's very much like a Da Vinci Xi in terms of its format, with a large boom at the bedside, four arms hanging off it, tower and console. So let me talk about the main component first, which is the bedside cart, which is a very big, and I mean very big, bedside cart. And you have basically a tower that comes up the middle of it, and then you have a boom structure on the top, and the four arms hang off it. Now, very interestingly, and this was a little bit of insight that I got from the company, their arms have 8 degrees of freedom. And if somebody says, well, what do you mean by degrees of freedom? It's basically how they can move in different directions. So there's 8 ways that it can move around in different directions, up, down, left, right, in, out. Most arms have 7 degrees of freedom, and they've put an extra joint in there that gives it another degree of freedom. And we'll talk a little bit about that later. But what it means is that from the straight boom structure that they have rather than X boom structure, you can bring the arms into the positions that you need so that you can approach the trocars or the ports in the patient. No matter which quadrant you go into, they're able to approach those trocars in an easier way because they have these 8 degrees of freedom. And then we'll talk a little bit later about how that 8th degree of freedom can be used to help to reposition the arm on the fly and avoid some of the arm clashes. So I found that a very interesting insight into the Hinotori. Again, all of that, these are all great things in the lab. They're all great things in engineers' minds. Does it translate to something meaningful in the operating room? I think we're going to have to wait and see that because there are only about 3,000 patients in and not in every specialty. So I think we'll wait a little bit to see where they get to with that. One of the important things on any robot is the arm architecture. And they have a fairly short Z rail on their arm, which is the way that they mount. And you can see my other podcast where I talk about Z rails a little bit. So basically you have a Z rail mounted off each of the 4 arms, and you can mount onto them an instrument, or you can mount onto them the scope and the camera system so that you've got your visualization. And what I understood is that they are 8 millimeters on the instruments. It takes a standard Storz 3D HD camera system and scope. So port hopping won't be that good for now, but if they get to an 8mm scope, they'll be able to do that. But I think it gives you choices of where you want to put your scope on which arm to best suit the quadrant you're trying to get to in the patient. So I think that also is quite an interesting thing that they've got. The arms I found to be very thin. Of course, they're strong. I mean, Kawasaki knows exactly the size of an arm and the power of an arm that you need to move certain payloads and weight loads and get all the power into the patient that you need. So I'm not concerned at all. But it is nice that they're thin because, again, you take that and you combine the fact that much like Senhance and CMR, they have decided to go for a system where you don't dock the arm onto the port. And that means, again, you don't lock the end of the Z rail onto the trocar. What they've done, just like Senhance, is to do software-driven pivot point finding. So the fulcrum of where the instrument's going to go through is found and managed through software. And I suspect that that's going to allow them a lot of advantages in the future when they're going to be able to have table movement, because through software, they'll be able to readjust the pivot points on the fly if they put those two things together. That's one of the benefits. Another benefit of software-driven pivot points is that you can really control, or you can understand how much force is at the pivot point. So you can either stop the arm moving to make sure you don't damage the patient, or you can adjust on the fly, which I suspect they can. You can adjust on the fly where the pivot point is in 3D space and ensure that you always have the minimal force being applied to the trocar, therefore being applied to the wound in the patient at all times. So I think these are some interesting things, and it comes out of a philosophy. So again, if you've dealt much with Japanese companies and Japanese medical device companies, generally they're more driven by philosophy than they are driven by just pure technical gains. So what do I mean by this? It was interesting talking with the Medicaroid team that their philosophy was that they feel that generally Intuitive has set the correct architecture for what people want. And the way it was described to me, which I quite liked, was somebody decided to put the accelerator on the right-hand pedal and the brake in the middle and the clutch on the left. And everybody who drives a car just knows that that works, okay? So their philosophy as Japanese is that certain things of this, the surgeons have got an inherent ability to already use, those who are already doing robotic surgery. And if you want to flip between systems, keeping it so that the accelerator is on the right and the clutch is on the left is probably sensible. So that was a philosophy decision by them to keep as much as you can the same. So again, another thing that's we'll talk about in a minute is the console. So they have a console, and on that console, they use very similar finger and thumb pinch grips to Da Vinci because they feel that that's what's kind of out there as the main thing. And they also believe in the 3D visor effect, i.e. putting your head forward into a 3D visor. But what is quite cute about the Medicaroid system is that the visor is not two big television screens. It's a custom-built Sony headset that can be adjusted. And this is quite nice that you look into the periscope, but you're able to bring the periscope to you. And I've had lots of surgeons over the years complain of neck pain when they've had to lean forward into the intuitive system. And this is a way that you can keep your head up and your head centered above your neck for the procedure, but still look into a 3D visor. Now, why is that different than intuitive? The original, and I don't know if they still do it, and someone from intuitive could say, one of the original ways that intuitive helped to trick your brain into doing better surgery was that your line of sight vision, if you look through the visor and you then took that visor away, where the instrument tips are on the image screen, your fingertips would be in space, if that makes sense. And I probably didn't explain that very well, but the direction that you look down, it's as if you're looking down at your fingertips. The problem is with a Hinotori, if that is really what makes things easier. Some people don't think it is. Most people say you don't drive your car by looking down at your steering wheel. But if you put your head back, do you lose some of that sensation of being able to see where your fingertips are? So it'd be interesting to hear from some surgeons who've used both systems and see whether that really or doesn't make a difference. But I think people who will listen to my podcasts and read my blogs know that I'm more of a fan of the open systems. And what I mean by that is open screen systems. I believe that laparoscopists, who are going to be the main people coming over to robotics now, are very used to being in an open environment where they look forwards to a screen. They can see the patient underneath them, the bedside team around them. There's really clear communication between the bedside team and the surgeon. They can see everything that's going on and have a really clear situational awareness. Just like with Da Vinci, if in Medicaroid you go into the visor, you lose some of that connectivity with the operating room staff. And in fact, they must be aware of that because they've built into the headset a microphone and an earpiece into the headset so that they can retain communication with the team. Again, I think the market's going to decide, right? There'll be people who really like to go off into their splendid isolation and look inside the scope and get that really immersive sensation of being inside the patient as if you're inside there. Whereas others really like to be out and with the group and with the patient and in a more open environment. And I think it'll be a preferential choice surgeon by surgeon. There are a couple of companies out there that are doing both, which is there will be an open screen for when you're doing the majority of the work. But when you get into the deep, fine things like an anastomosis, you bring in a headset just like this, like a periscope headset. You go into the immersion and you live inside the patient for that moment of the anastomosis so that you have that really deep, concentrated, immersive feel within the patient. Again, going to be interesting to see how the market reacts to all of this. And then you have the third component, which is like a lot of the systems have out there, which is a standalone tower. So you have the stack or the tower. And on that, you have a lot of the computing power. So there's a big computing box. You then have the 3D HD stored system on there, and then an electrosurgery generator and a screen for the rest of the team. And you can put the insufflator on there. And they're the three components that you make. The problem that I see with this, again, is that when you follow the XI format, you tend to follow the XI dimensions and size. And I've not got the actual spec sheet of Medicaroid, but it's going to look at about 1.5 metric tons or plus for the whole three components. I watched a video of it being delivered into Aussie, and you can find it on YouTube. It being delivered into Aussie, and it packs down quite well and quite small. But I guarantee that if anybody goes and watches that video, they're going to understand two things. Number one, how big the system is. But the second thing they're going to understand is you are not going to be moving this system between operating rooms. It's really clear. That bucks the trend of where everybody's going. So the one trend they're booking is that everyone's starting to move towards open consoles with open screens. And the second trend they're booking is that they're getting to smaller systems and more mobile systems. And especially when we're going to get more and more patients in the future done in things like ASCs or clinics or smaller operating rooms around the world, I think that The wisdom in following the Da Vinci design, i.e. accelerate on the right, brake on the middle and clutch on the left, has got some merits. But I think that the downside of that is that I imagine that Intuitive is going to come out with a smaller, lighter, more capable system that'll be more mobile, and they're going to be left 2 generations back. Medicaroid will be left 2 generations back with these big systems when everyone in the market is starting to move to these open systems or especially more mobile and light systems. So I think that's a little bit of a struggle that they're going to have. Just want to come back again and say, I just want to reiterate again, because I think one of the clever things that they do have in there is if they've got really good clash avoidance, which is different than clash detection. So if the arms can take advantage of that 8th degree of freedom and allow that the arms avoid clashes and collisions, I think that will be a massively appreciated feature of that robot compared to the ones that are currently on the market. So I'm really looking forward to see that and to see if that actually works, which will be cool. From what I've understood, they've got regulatory approval in Japan, and there's a certain set of procedures that they can do. But definitely they can do urology, gynecology, and I think they're doing some of the general surgery. They've just got approval for the use in Singapore, and CE mark is, I imagine, is literally around the corner. They've had an office open in Germany for a long time, and I know that they've been doing their submission. So I can imagine that potentially in 2024, the system will be available in Europe, which will be cool. And I know that they've got an office in the US, so they're obviously, and you have to target the US, so they will at some point in the future be also going for FDA clearance. And then you'll have basically the major markets to go for. There is, with Japanese products, there's usually a fandom within Japan. The Japanese like to have Japanese-built products. They're very nationalistic in their choice of products. So I think it's done really, really well in Japan. It'll be interesting to see how it does in Singapore. And then Europe is where I think they're going to have probably a bit of a harsh reality. So let me try and talk a little bit about this, which could be one of the problems that I foresee for them. The gold standard today of the large format boom robots is the XI. It's the king. There is no doubt about it. I think it's probably the Swiss people listening to this, and if someone from Digital Motion is listening, they'll probably be upset with me. But it's the Rolex of surgical soft tissue robots today. I feel it's like the Rolex. So you come out with another watch, and I'm going to use a Japanese brand of Seiko. It looks like a Rolex. It's actually probably keeps time a little bit better than the Rolex. It's probably battery powered, not self-winding, and some different things. But it's more or less the same cost as a Rolex. I guarantee you the majority of people, if you've got those two decisions, will go for the Rolex. If anyone is going to want to really have an immersive visor with a big boom robot, why wouldn't you go for the one that's tried, tested in 12 million patients, has the full range of instruments, has advanced instruments, has advanced imaging? Why wouldn't you go for that? So that comes to the commercial side of what they might have to do. The switching cost between robots, from everything I've seen, is that unless you're 30 to 40% cheaper than the competition, if you're a similar form factor, you're not going to get the investment for the switch over of the robots. So the training, the retraining, resetting the sterilization systems, stocking to robots, etc., etc. Now, people say, oh, yeah, but the price of the robot is not the cost. I know that. What I'm talking about is that if the cost of ownership on a day-to-day basis, so if your cost per case can't drop by 30% and your total ownership over 7 years, including servicing, support, training, instruments, drapes, advanced instruments, the actual robot, data systems, all of that, if you can't get a 30 to 40% saving, in my mind, I don't think that customers are going to decide to choose something that's very similar, that has a similar function, a similar format, and doesn't have anything more interesting to offer. I do think that Medicaroid is going to have a little bit of a battle on their hands, which also means then that the other thing I don't think they're going to be able to do is to sell the robot as an upfront capital across Europe. That may change in different places, and if people have got charity monies or there's money they have to get rid of, then yeah, they could. But I think generally what's going to happen is, and this is the trend in the market, people are going to have to put the robot in and then have a leasing or a rental or a cost per case. That would be different models. And I think as you get closer and closer to a DaVinci Xi, more and more it's your commercial model that will have to be the differentiator to make it even slightly worthwhile that somebody does the switch. So it's going to be interesting to see how they come out with a commercial strategy in Europe. Now, Kawasaki and Sysmex, they have deep pockets, right? They have really deep pockets, but this is a spin-off venture. And yes, they might have deep pockets as the mother companies, just like J&J and just like Medtronic. But there's a limit. The quarterly cash flow is going to be more important than the deep pockets. And this is what every single new robot faces, which is not having the install base means you don't have the revenue stream coming in on the instruments or the service. So you have to build your revenue and your cash flow slowly. And every time you give a robot away, you give away a lot of money that you have to make up. And Intuitive can do this now because they have a huge install base, because they had a monopoly for 20 years and they were able to grow that install base. They were able to sell capital equipment, and they've got that cash flow behind them now already. Any other company coming into this, just looking at their pure robotics model, it's going to be demo systems that they've got to put out there. It's going to be training systems they've got to put out there. They're going to have to place the capital and then work out how to get that money coming in through the revenue stream of rentals, leasing, instruments, drapes, all of those things. And you're trying to do that, making it 30% less cost of ownership than it is for a DaVinci. So the pricing is also going to be under pressure as well. So it's going to be really, really tough. And it doesn't matter how big and deep your pockets are. Same for Medtronic, same for J&J, but the same for Kawasaki here is I think it's going to be a dawning realization when they get about 12 months into this and they don't get the kind of commercial traction they thought. It takes way longer, 18 months, 2 years, as I've said in other posts. I think that's when there's going to be some dawning reality. The second problem that you're going to have is that you also don't have quite the feature sets. So they've got some nice instruments, and I found out from talking with Medicaroid that they make their own instruments, which is really good. They obviously get components, but they build their own instruments. And you would imagine that a really high precision engineering firm like Kawasaki can do that and do that well. I've seen the videos. They look very similar to a DaVinci instrument, and they have a very nice fluid movement. They seem to grab well. They seem to work well. And they have the basic knife and fork set. They don't have a hook. I saw again they didn't have a hook. So that's clearly becoming a theme out there, that making hooks is not that easy. But they do have 2 types of needle holders, scissors, graspers, Maryland dissectors. And then they also have like a long grasper with an upward tip, which will be good for thoracic when they come to thoracic. But they are basic instruments with basic function. They also have a very basic image system. So it's a 3D HD, similar system to what's on the Hugo. Nice picture, really good 3D HD, but it's already 10 years out of date. And as people bring out 4K, 4-chip, ICG, and other imaging modes, that imaging system is going to get left behind. So you'll end up with a same form factor, same kind of visor. You end up, though, with a much more mixed amount of instruments that you can use. And then the second problem that you're going to have is what every other robot's going to have, is the range of procedures that you can use with it. Because when you come out in Europe, you used to be able to come out and put a robot on as the product and do all the procedures. Well, now you can't do that. Under the MDR, there's a change, and you can only bring the robot out and have limited procedures and then do trials and present data to get more procedures. So they're going to come out also with a robot that's just as big, just as heavy, with the visor, instruments that are very similar but basic, and you will only be able to do a limited number of procedures. So that then means you've got this 12 to 18 month commercial window when you've got to sell it, and you've got to be playing catch up on instruments and catch up on procedures. So I think it's just going to be a really difficult sell. And I personally would not want to be out there selling a Me Too version of a DaVinci Xi. Hopefully some of the features that are in there, people are going to really, really like. If the 8th degree of freedom avoids clash and you get better clash, if they get a partnership going for visualization with ICG, they get a partnership going for advanced surgical instrumentation, such as advanced energy and stapling, then I think they'll be able to stay in the game, and it'll be a good alternative. And it'll all come down to what's the cost of ownership over 7 years, and will there be a 30% saving? So looking at what they've done so far, I looked on their site, and there's a very nice presentation. Shame it's in Japanese and I didn't understand it, and closed captions. So just if Medicaroid's listening, you might want to get some English subtitles onto that. It's a very nice presentation of the Medicaroid Hinotori system on YouTube. It's about a 45-minute presentation. And in that presentation, there's two things that were quite interesting, and you can find press releases on this. One is that they've done over 3,000 procedures already across a range of specialties, which is pretty cool. And the other interesting thing that I saw in there is, I personally think it's a gimmick for now, because you'll hear why in a second. They have been able to do some 5G long distance teleoperation of the system. And their system is built to do that, as many systems are. But their system is to be able to get images fast and to get the data to and back from the robot very fast. And they've actually done some 5G distance procedures. And that may well work in Japan, where, from a regulatory point of view, a surgeon in one city is legally allowed to operate in another city. There's nothing problem with operating rights. In places like the US, operating rights will start to be a problem with that. And then the other thing will just be is, if I'm a busy surgeon, do I suddenly have time to be going off and doing learning curve cases with somebody else there? Yes, proctors do it all the time. So can I proctor from a distance? Maybe. But I think the whole thing of the distance teleoperated systems, for me, is a little bit gimmicky today, but I'm really happy to be proven wrong on that. And when in the past people have talked about, which has been a bit waffly for me, the democratization of robotic surgery, I think that is one of the features that will help towards that eventually. But I just struggle with it in my head today. So let me wrap up. The real pros that I've seen from the Hinotori is the incredibly high quality. It looks super smooth in the way that it works. If you can drive an XI, you can drive a Hinotori. It's just the same. They have great imaging. The HD 3D is great, but it will soon be superseded. The visor system, for those that really like to put their head into a visor, I do quite like this thing where you can bring it to you and get yourself into a good ergonomic position with your neck. Whether or not that will be a little bit more difficult to use, we'll have to see. And for me, the big thing, that if they've got this arm collision avoidance, that is one of the banes and the pains of robotic surgery. And if they can nail that, that will be pretty cool. On the downside, for me, just way too big, way too heavy, not mobile enough. The pros of it being close to a Da Vinci are it's easy to adapt between the two. The cons of it being close to a Da Vinci is then I'll go and buy a Da Vinci. So I think the commercial model is going to play out in that. The company has very deep pockets. They've teamed up with Orsi, got some good training going on. I think they've got, Kawasaki know how to service stuff and do it. I imagine they'll also be able to build this thing at scale using their own technologies from their own heavy industries, robotics things, and they might be able to get the cost of this down significantly. So that could be the commercial model could become quite compelling, because they'll be able to drop the price probably of the manufacturer of the robot. Not so sure on the instruments. Generally, it looks like for those who like a big boom system, I think there's a really credible alternative out there for people to try. So thanks for listening to the podcast. Catch me next time on MedTech Mavericks podcast, and I look forward to seeing you then. Bye-bye.